Okay, and to the audience, if you have specific questions, just raise your hand during the interview and I will come down with the microphone to you. Okay, Dr. Hille, can you please shortly introduce Salzgitter and the aims of your department?
Yeah, thank you very much, Mr. Haag. Salzgitter is the second biggest German steelmaker, and we are operating an integrated steelwork in Salzgitter, which is around 70 kilometers from here. Our annual output is about 5 million tons of crude steel, and we are focusing on high quality flat carbon steel products there.
Okay, 5 million tons of steel.
Mm-hmm.
Yeah, how is primary steel produced today?
Yeah. In Salzgitter, as nearly everywhere around the globe, this range of products which we are focusing on is produced via the so-called blast furnace route. So, meaning producing fresh steel directly from iron ore, and this is done on a coal basis. So blast furnaces are operated nearly on a 100% coal basis. And this, of course, brings us to the topic today, the inevitable formation of CO2 on this route.
Yeah, and connected to this, you made up a new phrase, CDA, or carbon direct avoidance. What does it mean now?
It means that we, in our decarbonization strategy, want to take advantage of a special asset of steelmaking, which is quite unique in this industry, and this is the possibility to replace carbon as reductant, that means as the agent which removes oxygen from iron ore, to replace it by hydrogen. And this, of course, means if before you form CO2 in the process, with hydrogen you only produce water, H2O. And this is what we're targeting at. And we coined this term to distinguish ourselves from the well-known CCS and CCU approaches for decarbonization, which aim at basically keeping processes as they are today, so fossil-based, and just use or, let's say, final deposit CO2. We say we have the possibility in steelmaking to address the topic directly at the root. So direct avoidance of carbon usage or direct avoidance of CO2 formation. It is in principle, it's the same. So this is the reason why we coined this term. And we recognize that it has made a good start. So it's widely used already in politics and in industry.
Okay, so and you develop now a low CO2 steel making. Now Salzgitter launched a project SALCOS. It's called SALCOS. When did you start it, and which targets especially did you set?
Yeah, we started around 4 years ago, so 2015. And when we started, we formulated some internal guidelines which we wanted to follow in the course of this decarbonization project. And we said, first of all, carbon leakage is no option for us, meaning everything we do, we'll do it in Europe. We do it at our site. And we wanted to go into a direction which offers industrial scale decarbonization at a very early stage, meaning no lengthy laboratory scale studies. We want to reach something substantial early. The next thing is that if you consider the scale of steelmaking today, it's nearly impossible to change everything at once, meaning one big step forward and that's it, fully decarbonized. This is nothing which is realizable in our real world, meaning that we have to target a stepwise approach, but with considerable CO2 avoidance right from the start. So it will take some 20, 30 years to completely change the processes which we are running today, but we can do it
step by
step.
Yeah, and this is my question. What's the basic principle now of SALCOS? What does it mean, step by step?
First thing is, this is something you have to keep in mind. Blast furnaces are operating on nearly the lowest carbon input possible, because of course energy costs money, so the steel industry has optimized its processes to the lowest possible input set by laws of nature and and engineering. And so it's not possible to substantially decrease CO2 emission from the existing processes. So if you want to do something really valuable, then you have to change the process, because blast furnaces never can run without coal. So and they are reactors which are optimized for solid coal input. So first of all, you have to change the type of reduction reactor. And fortunately, this type of reactor already exists in the small niches which are in the world where coal is more expensive than natural gas. And these are, for example, in Northern Africa, Middle East, Indonesia, around the Gulf of Mexico. These are the locations in the world where natural gas-based steelmaking already does exist. And the type of reactors I'm talking about are the so-called direct reduction reactors, operated on a natural gas basis. But if you consider that we are coming from coal, changing over to something which is at the moment natural gas-based is already a big step forward, leading to savings of around 50% of the CO2 emissions which we currently have. And the very nice feature of these special type of reactors is that they can be operated also with hydrogen. So not only 100% natural gas or 100% electrolytical hydrogen, but everything in between. And this means that even if we probably do not have the hydrogen supply already today, which allows us to operate them purely on hydrogen, we can start technically, virtually now, with a natural gas plant and enhance it with ever-increasing shares of hydrogen. So do something now without spoiling the future. Okay. This is the basic idea.
So you could already build this new reactor that you know from Northern Africa. What did you reach until now? Have you been built such a direct reduction plant already?
Not yet, because there's not a technical issue with that, but probably I should add, it's not only the reactor for iron ore reduction, but of course you have to think about additional plants. That means the new type of reactor produces solid iron, hence the name. Direct reduction means direct in solid stage. You put solid iron ore inside, you get solid iron out. So if you want to refine this, if you want to alloy it, shape it, then you first have to melt it. And for that you need an electric arc furnace. So you ask, probably I should add that, at the beginning you ask for the basic principle of our approach. We could put it like that. CDA, carbon direct avoidance, means incremental electrification of primary steelmaking. Indirect electrification via increasing shares of electrolytical hydrogen. Of course, this is indirect electricity via electrolyzers. And direct use of electricity for the supply of process heat for melting the iron produced. So, and this in ever-increasing shares. It's a little bit like electromobility.
Okay. So it means step by step.
It means step by step.
Using power consumption for more and more steps of the primary steel making.
And as we are aware that electrical power for complete hydrogen production is not yet available, we have always this fallback option of natural gas. Yeah? So this is especially important for securing our productivity, because our customers, in the end, they don't care how we produce it. They want to reliably be supplied with quality steel.
That's for sure. One step back, maybe again, what were the main driver for you to start this project? Is it your emphasis for our environment, or the fear of rising costs for CO2 certificates, maybe, that are now talked about?
both. Yeah, but I have to emphasize that rising CO2 costs are not the suitable driver for incorporating decarbonization projects in our industry or
Why not?
also, because steel is a worldwide traded commodity, and what we are targeting at is keeping the production. If we manage to keep the production costs as they were with a standard process plus CO2 certificates which we have to buy, when we run the new processes with lower CO2 emissions, we probably don't have to buy them, but as we are using electrical energy, natural gas, and we have higher cost energy supplies. So it will be, if we manage to keep on the same level, including the CO2 certificates which we need, then we are good. Meaning total production cost is likely to rise. That means if we have ever increasing CO2 cost, we have higher production cost. But the problem is that decarbonized steel at the moment is not incentivized. That means at the moment no customer is able to pay or willing to pay any cent more for decarbonized steel. And this is our main task, creating a market for this product.
Okay, I understand. For using hydrogen in such an industrialized process like primary steel making, which size of, for example, electrolyzer stacks are we talking about?
If we target a first implementation scale of our project, meaning one direct reduction plant of 2 million tons per year for replacing one of our blast furnaces and the subsequent basic oxygen furnaces, we would need around 80,000 cubic meters of hydrogen per hour to supply 1/3 of the energy necessary in the reduction process. Not 100% because that's not sensible at the beginning, but for that supposing you have an 0.7 electrolyzer efficiency in the future, we are talking about minimum 330 megawatt electrolyzer capacity for our plant alone.
330 megawatt
Yes.
in electrolyzer. Okay, so a big task.
Minimum, depending on the operating hours.
Yeah. Operating hours is a good point. I heard that the process is, of course, the investment cost is the best when you when the full load hours, you drive at maximum full load hours. With which full load hours do you calculate? I mean, is there a chance to react on different levels of energy demand in the net? Did you? Yeah.
Yeah, we could do. We are, as I said, this is a special feature of our concept, as we have the natural gas basis always. We could, and hydrogen as a surplus. It is not necessary to run the process technically. It improves the CO2 emissions, of course, but when it's not there, it doesn't mean we have to stop production. But the thing is that we don't believe that processes of this size can run on only surplus electricity. And this is the first thing. And the second thing is, if somebody believes he gets this surplus electricity for free, it's the second thing we don't believe in. What is necessary to deeply decarbonize steel industry or also chemical, whatever mobility, it's a continuous supply of renewable electricity, not only surplus. So the big task is supplying society with reliable, continuous shares of the needed electricity.
Okay, thanks. So, and you want to do you want to be active now? You want to do this investment? You want to implement these modules? Which kind of contacts are you looking for in Hannover now?
Probably I should say what we are doing with our project is we are making an offer to society. We have been asked to decarbonize our processes. And some people say, technology is not available, energy is not available, and political framework is not available. And what we show with our project, with our concrete proposal, is technology is there, and the energy to start it is also there. And the third thing is the only thing which we think is a real reason for not a reason, but the problem why we can't start, that is the framework. So this is what we try to do. We are saying we can do anything you like if it's possible to create a market in Europe for decarbonized products. And this is not existing yet. And this is our main task. And when you ask contacts, these are the kind of contacts, basically to NGOs, to politics. And that is what we're searching for.
Okay, so we still have to adjust the framework. Thank you for this look inside. It was really interesting to talk to you. Thank you, the audience, for being here and joining us. Yeah, and everyone who is interested in this topic, you can talk to Dr. Hille in hall number 5, booth 6, which is not here in this hall, but how long does it take to get to you?
It takes quite a walk, so it's 10-15 minutes. Yeah, it's on the other side of the area.
So take your chance and talk to Dr. Hille now.
And not only talk, we have a very nice virtual reality installation of our project, where you can have a close look how it would like if being implemented in our integrated works in Salzgitter.
Okay, thanks for that. Thanks, Dr. Hille.
Thank you.